All right, so here are the instructions for the Google Sheet. This is the way you should encounter it. So there's a number of blank spots here. These here are the two very large prime numbers, 3 and 11. And then this one here is the product of them, which is the modulus. So 3 times 11 is 33. I'm going to take this out here while I let you do it, but obviously it's 33. And this one here, that's the Euler-Totian function. So subtract 1 from each. So it's 2 times 10, which is 20. And I don't mind giving this away. This one here, I will not necessarily give away. I will show you how to do it. You take the 20 and then yet another large prime number, the 7 here, and you put that into the inverse modulo calculator, just like that, 720. And I let actually you do that and see what you come up with here for the solution. That actually will go in here. Okay, so I'm just going to make something up here, for example, 4, which is not the correct one. Notice that it decrypted here actually. Now what happens over here, what you see here, encrypted and decrypted, and you see all these error messages here. Well, what happens here is that Excel, or in this case, the Google Sheet, is not able to actually do it. So it takes, for example, here a number and it takes it to the 7th power, which becomes a really large number. And then it divides by the 33 here. And apparently it just, here it can handle it, but not on the next one. Apparently the number just gets too large. So therefore, you see the modulus here right there. Therefore, I put this one over here where I rewrite the formula. And if you carefully look, notice the MOD here for modulus, right? And then over here, you see it twice. So there is again, it's not a mathematical trick. It's just a property of how modulus works, that you change the formula and you apply it twice. And now actually a Google Sheet can do it. So you see, for example, here you get a 30, you get a 30 with the other method, 14 and 14, and they're all equivalent. And now it can actually do the numbers in between and get you a corrected one. So this one is actually the correct encrypted one. This one here, well, because I'm using the wrong inverse modulus at this point here, these are actually not correct numbers, okay? You would have to figure out this one here first for yourself, what it is, and it's not very difficult. And then plug it in there. Now this one over here, because the decrypted one only gives you very small numbers, you would have to see, okay, do I just take this to be one time here? So 15 actually is the one. Or do I add that 33? Notice the next one here. Well, this one here, kind of like behind it should be like a 33 added to it, so 48. And then this one here should be another 33 added to it, so kind of like 81. So then pull this one down. So you have to plug in these numbers, 1, 2, 3. Plug this one down here. And then you look across here. Remember in the big video that I gave, bank account number 1, 2, 3 was the solutions, and you had to go across here these 3 lines and figure out what it is. There's nothing here because, again, this is actually the wrong one. But that's the instructions for this one. So these are the steps that you have to do. I'm going to take this one off. So you would have to fill that in by, oops, excuse me, by pulling this square down all the way. Okay. You have to fill this one in, 1, 2, 3, no big deal, right? This one here, you have to find it from the inverse modulo calculator from the 7 and the 20 here. I'm going to take it off right now. And then these here, you have to compute 3 times 11, 2 times 10. So there you go. And then you will get a message in here. Those are the instructions.